starting our review on chapter 12, DC circuits. Of the three chapters that we had, number one, chapter 10, which is on electric fields, and then we've got the current of electricity, and the peak ataupun dia punya pinnacle dalam nak cerita tentang circuits ni ialah ataupun electronics ni ialah DC circuits lah, where the main theme is revolving around Kirchhoff laws, the Kirchhoff first and second law, which is actually corresponding to current and voltage law respectively. Although we had actually the discussion on the practice questions last Friday, if I'm not mistaken. So on that topic, it's actually just the first part of this circuit kan. It's only discussing on the potential dividers. So this is actually the second part. The second part. Although the question on potential dividers, if as you have already noticed, do come out, especially in the objective question. So overall, I think you guys did a good job, regardless of the mark. Walaupun ada yang dapat 50%, tapi it's okay. Given the current circumstance, I think you have done good. It's a matter of practice, and if there is any problems in terms of the subject matter, understanding of the subject matter, do not hesitate to ask me directly. Inshallah, I'll try my best to respond in the best way possible. Okay?
Sir.
Yes. Okay. All right. Question number 1. So the diagram shows part of a circuit. What is the current X? So awal-awal lagi dia dah cuba untuk nak uji tentang Kirchhoff current law, the Kirchhoff first law. Well, how do we know that it is the current law? Because it all involves the currents kan. So yes, it seems as if dia macam branches lah kan, Although we know Kirchhoff current law states that the total sum of the input current into a node / branch / junction / section, maknanya anything that goes into one point, the total amount of current into that point must be equal to the total current exiting ataupun leaving that point itself. Tapi kalau dalam kes ni macam mana? Dia sama ada kita nak tengok dia punya branch, sebab takut-takut kita ada parallel currents and what not lah kan. Semuanya, one way of representing this is actually by redrawing the circuit in a manner that might be easier for us to perceive. For example, for this one, notice kita nak tahu total current into the node. So let's say we have this one node, and then kita define 3.4 amperes and 1.3 amperes as the two nodes entered as the two currents that are entering. Macam mana kita tahu dia entering? Because dia punya direction lah kan. And then we've got the three currents leaving. So tapi sebelum tu kita tengok the sum lah. The sum is 4.7 amperes. And then the total current out of the node, okay, we can define it by this. Macam tu sajalah. Okay. Tapi dia tak semestinya macam ni lah kan. It's up to you. Macam mana you nak perceivekan benda ni. As long as you know the concept of the total current into and output must be equal. Okay. So here you have the first equation lah, ataupun the variable, the current X that we need to define, that we need to find out. So using Kirchhoff first law, in out, so X equals to 0.6 amperes. Okay. Kalau siapa yang dapat salah tu, kalau nak query, nak tanya, boleh terus tanya lah. Tapi this how you do it lah. One way of re-representing it is by using this the diagram on the red color yang saya tunjukkan. Can you guys see my arrow?
Yes.
Cursor,
Yeah.
Adalah Saya pusing-pusing, so tak payah guna laser pointer lah kan?
Yeah.
Okay, that's good. Okay. What about this box? Ada nampak box ni tak?
No box.
No box, there's no box. Alright, good. Okay, the diagram shows a junction in the circuit. So ni sama juga, cuma yang ni dia represent dalam bentuk node lah kan. So what is the current Y? So kat sini, kalau kita guna, we use back the steps that we did for question 1. Kita akan tahu total current into the node is 3.0 and 0.4, and then we've got 3 currents that are assumed to be leaving the node. Tapi bila kita kira-kira, tengok-tengok dia punya value of Y is minus 0.2 amperes. Kan? So what does that show? If we have a current at minus 0.2 amperes,
It's going up.
sepatutnya yes, sepatutnya Y ini is going inside. Is actually an input current. Cuma kalau kita punya arrow dia into the node, so maknanya Y ni dia akan jadi positif lah. Okay. So you have to be careful If you have a positive, that means it is going into. Tapi tak semestinya positive tu always referring to into the node Just because of this notation, when we assume that initially Y is going outwards. So initially Y is going outwards, and then when we do the calculations, we find out that Y is equal to minus 0.2 amperes. So because of that, we know that the direction of Y is actually going into the node. So kalau awal-awal lagi kita dah define Y ni into the node, maknanya kita akan dapat positive value lah instead of negative kan. So that is the difference. Okay. Question number 3. Welcome Naufal. Selamat datang. The diagram shows the circuit. Naufal sensitive kan? No, class at 2 o'clock sir. 11. The diagram. Masuk dia datang lewat sikit. The diagram shows the circuit. The current in the circuit is 0.8 amperes. What is the EMF of the cell E2? So kat sini dia guna Kirchhoff voltage law. Okay, which is the second law. Nak tak nak kita boleh assume anti-clockwise direction as positive. You can do macam soalan hari tu dalam group kan. Ada yang tanya, why must it be positive atau why must it be negative? It all depends on our assumption. Kalau saya nak buat assumption saya adalah negatif pun tak ada masalah. But you will get the same answer eventually, as long as the directions are consistent. Cuma kat sini saya define anti-clockwise direction as positive. Why? Because sebab dah alang kepalang dia tulis macam ni assume sajalah dia positif. Because of that, I assume this direction as positive. And then using Kirchhoff's second law, also known as KVL, dia kata apa? Dia kata, so sum of E equals to sum IR. So this is the formal definition of KVL lah. Ataupun in words, it would be the total sum of voltage supply must be equal to the sum of voltage drop within a closed loop. So yang itulah dia punya keyword kat situ. Voltage supply must be equal, total voltage supply must be total voltage drop in a closed loop for Kirchhoff voltage law. Okay, and then you substitute everything. Since this one is positive and this one is positive, so kita consistent lang So E1 plus E2. So this is the supply. Okay. And as for the voltage drop, you've got two components here, IR1 and IR2. Since both of the resistors are arranged in series, so we can assume that the current is the same, flowing to both of the resistors. So substitute, you get the value as 0.8 volts. Okay. Me at any time. Yes.
If the terminal for E2 is changed, so it means that we have to write down E1 minus E2, right, sir?
Yes. So thank you very much for the question. If we have a scenario, a scenario in which the polarities of E2 is reversed. So in this case, because we assume all of the direction in the clockwise, all of the direction in the anti-clockwise is positive. So in this case, E2 is actually opposite direction. So kat sini kita kena define, instead of E1 plus E2, it will be E1 minus
E2.
Minus E2. Ataupun sebenarnya E1 plus E1 dia akan jadi E1 plus juga sebab dia total sum kan. Kita letak dalam kurungan lah kalau nak more visible lah kan. Itu kat situ. Okay ke?
Okay. Mine.
Sorry for that, I got disconnected.
Okay.
Okay.
Tiba-tiba senyap Okay, sekejap I have to end this call, end this meeting, and then saya send balik. Okay, sekejap.
Yeah.
Alright.